Hello students, so in this video we are going to discuss the previous year questions on this topic and these questions are the recent questions 2024 January attempt. Okay, so let's start the discussion. A ball of mass 0.5 kg is attached to a string of length 50 centimeter. This is a string attached to a ball. This is a ball and there is a string attached to this. Ball is rotated on a horizontal circular path about its vertical axis. So this is the axis of this vertical axis and ball is rotating about that vertical axis. That means it's a horizontal circular motion. The maximum tension that the string can bear is 400 Newton. Maximum possible value of angular velocity of the ball in joule per second. So tension maximum is given. Any kind of rope or string will have a maximum tension because if you keep on increasing the tension, it may break at some time. So that's the maximum tension at which it can break. Okay, we have given this. So we know tension is providing the centripetal force here, v square by r or m omega square r. They are asking angular velocity, so we'll write this equation. So tension must be less than equal to maximum tension, and this tension is m omega square r less than equal to 400. From here omega we will solve. Mass and radius are given, substitute, you will get 40. Right, so that's the answer. Let's move to the next. That means here option 2, that's the correct answer. Okay, let's move to the next. So next question, a disc of radius r and mass m is rolling horizontally without slipping with speed v. So there is a disc here, you can see this is a small disc which is going, and this v is the of course velocity of center of mass. Okay, and it is climbing over this smooth inclined plane. Okay, smooth surface. The maximum height that the disc can go up the inclined plane. What is the maximum height? So here you need to first of all note that they have given that it's a smooth surface. That means there is no friction. So friction can provide a torque which can affect the rotational motion of the body, but rotational motion is not getting affected because the friction is not there, right? Mg and normal, two forces acting, they cannot affect the rotational motion because the torque about center of mass due to these two forces are 0 because the line of action of these two forces passes through that, right? For example, this is that, and the normal goes like this, right? And Mg goes like that. They do not affect the rotational motion. So kinetic energy total is made up of rotational and translational. So rotational kinetic energy half I omega square doesn't change, it remains same, but the translational kinetic energy is going to change as it is climbing up the stairs, right? So the energy which is going to is converted into potential energy is the translational kinetic energy. So at the bottom, the total translational kinetic energy half mv square. Finally, at the top, no translational kinetic energy, mgh, right? So that means total potential energy becomes half mv square. So from here, h is equal to v square by 2g. Simple, right? Option 3. Then let's go to the next. Next is 4 particles each of mass 1 kg are placed at the 4 corners of a square of side 2 meter. So 4 particles are kept here on the sides like this, and the moment of inertia system about an axis perpendicular to the plane and passing through one of its vertex. So perpendicular to plane and passing through one of the vertex. So let's say this is the axis, right? So about this axis you calculate, each are like a point mass, so mr square, mr square, mr square, mr square. First particle mass is at the axis, so distance r is 0. Second particle is at a distance of this side, which is 2 meter, 2 square. Next one is at a distance of the diagonal, 2 root 2 whole square. Third one is again at distance 2 square. So calculate, this is what is the total moment of inertia of the system. Answer is 16. Of course, this is in SI unit, right? Then next. Next question, a ring and a solid sphere rolls down the same inclined plane without slipping. So there is a ring and there is a solid sphere. Okay, without slipping they are going down. Okay, we start from rest, so initial velocity is 0. It is released. The radii of both bodies are identical, both have same radius, and the ratio of their kinetic energies is 7 by x, where x is So here kinetic energy again total is translation and rotational kinetic energy. So once it is going down, so the total potential energy is going to get converted into this total kinetic energy, right? mgh. So mgh will convert into total kinetic energy. So you can assume that they have same mass, although it is not mentioned in the question. We should consider mass same, because if you want to calculate the ratio of this total kinetic energies, because here they are just asking total kinetic energy ratio. So total kinetic energy ratios, if we are going to calculate total kinetic energy ratios, total kinetic energy must be same at the bottom, because the total potential energy initially they have mgh, the same mgh is going to convert into kinetic energy. So both of them have same total energy, same mgh. Of course here we are taking the same height and same mass, right? Mass also we have to assume same, although they have given radius same, but if they did not mention about mass, then of course we cannot assume any value of mass, right? But in questions, if they say mass of one is other n times or 2 times 3 times, then we can say that they may be different, but here we have to consider that the total kinetic energy ratios, total kinetic energy ratios mgh, height is same, mass also you take same. So that is going to be ratio 1, right? So 7 by x, x will become 7, right? Then let's go next. Next, a cylinder is rolling down an inclined plane of inclination 60 degree. Acceleration during rolling down will be direct formula apply. Acceleration, accelerated motion, accelerated rolling on inclined plane. G effective sin theta. G effective is g1 plus I center of mass by m square into sin theta. Just substitute the values. G sin 60 degree 1 plus. This is a cylinder, and you take it as a solid cylinder. If it is a hollow cylinder, they will mention in the question, right? So unless mentioned, you take it as a solid cylinder. So mr square by 2, and just simplify this, you will get this as 10 by root 3. So here x is the numerator, which is 10, right? Okay, next let us move to the next question. So a body of mass 5 kg moving with a uniform speed 3 root 2 meter per second in xy plane along the line. So this is the line along which the body is moving, right? This is the line of motion. Okay, the angular momentum particle about origin will be, so about origin means about this point. So you need to drop a perpendicular to calculate the r perpendicular, right? So r perpendicular directly you can calculate using the formula to calculate the perpendicular distance of a point from a line, right? So this is the formula for perpendicular distance of a point from the line, and the point is the origin. So you have to substitute 0 0 0 0, right? And then root under coefficient of x square, coefficient of y square. Both coefficients are one is 1, another is minus 1, but square will give 1 square, 1 plus 1 square, right? So you will get 4 by root 2. Once you get r perpendicular, angular momentum is r perpendicular into p. So let us just calculate r perpendicular. 4 by root 2 you substitute, and momentum, mass into velocity, mass is 5 kg and speed or velocity is 3 root 2. Substitute, you calculate, root 2 cancel, here you got 60, right? That's the answer. Next question, consider disk of mass 5 kg. Disk is mass 5 kg, radius is 2 meter, rotating with angular velocity. It is rotating with some angular velocity. Okay, with axis plane perpendicular to the plane of rotation. That means about its own axis, it is rotating. An identical disk is kept gently over the rotating. Whenever this word gently used, that means there is no external torque or force acting, and we are adding the another disk, identical disk over it along the same axis. The energy dissipated so that both the disks continue to rotate together without slipping this. So there is some loss of energy happening in this process. So what is the loss of energy happening? So we can try to calculate here conservation of angular momentum. First of all, when you are adding gently, the angular momentum will remain conserved, right? And the kinetic energy of the initial L square by 2I, kinetic energy final is L square by 2. Now inertia has become double because there are two disks now. Angular momentum doesn't change, but inertia has become doubled, right? So L square by 4I, loss of kinetic energy, initial minus final kinetic energy. You to subtract this, you will get L square by 4I. L is I into omega, substitute. So I square omega square, I got cancelled. So I omega square by 4. Now I is what? What is this I? This is a disk, right? So for disk, I is mr square by 2 into omega square by 4, mr square omega square by 8. Substitute the values given in the question. Mass is 5 kg, radius is 2 meter, omega is 10. Substitute and calculate, and this will give us the answer, right? That is 250. That's the correct answer for this, right? So such type of questions do come in JEE. Okay. Let's go to the next. Two disks of moment of inertia I1 and I2. Two disks of the moment of inertia is given about their central axis and normal to, that means the natural axis, rotating, and they are rotating with a different angular velocities. Okay, brought in contact face to face with their axis of rotation points, and they are just combined together. The loss of similar type of question, it is loss of kinetic energy. So same approach will follow. So angular momentum remains constant here. So initial angular momentum L1 plus L2 we calculate, I1 omega 1, I2 omega 2. They have given, right? I and omega, I and omega calculate. This is 48. So loss of kinetic energy is initial kinetic energy minus final kinetic energy. So initial kinetic energy half I1 omega 1 square, half I2 omega 2 square, minus final. Final we can just write in terms of angular momentum, L square by 2I. L square by 2. I means now it's a combined system. Combined system means both I1 plus I2. So let us just substitute here values, and once you substitute you can calculate this, that you will get as 24 joule, right? So this is how you may also calculate the omega, final omega, and final I. Anyway, you know that. Then also you can write final kinetic energy is half I omega square, but instead of doing this you can also use this approach, right? Fine. So I hope you have understood this. Then let's go to the next. A body of mass m is projected with a speed u, making angle of 45 degree. With this angle theta is here 45 degree. It's like a projectile motion. Angular momentum body about the point of projection at the highest point. So when the body is here, then what is angular momentum about the point of projection? Okay, so this type of thing we have discussed in the theory, right? So let us just do that. So angular momentum, when you see here calculation, first of all you draw line of motion. This is the line of motion, and you need to draw perpendicular on the line of motion. This is r perpendicular. So once you calculate r perpendicular is nothing but the maximum height, right? That's r perpendicular. So that is r perpendicular, and at this point it is a momentum only in the horizontal direction, which is mu cos theta. So this momentum into r perpendicular, that's angular momentum. So mu cos 45 degrees, substitute the values. R, this is the h max, maximum height u square sin square theta by 2g. Substitute the values, we will get this, and rationalize it, we will get 2 mu cube by 8g. So the denominator x, which is the 8 here, that will be the answer, right? Okay. So I hope you have understood this, right? Let's go to the next. So next, two identical spheres each of mass 2 kg and radius, these are fixed at the ends of light rod, so that the separation between the centers is 150 centimeters. So there is a rod, right, and the two spheres are connected at the end, and this distance between centers is 150 centimeter. That means this side 75 centimeter, this side 75. This is the midpoint, you can see, right? And they have given the mass of each sphere is 2 kg and the radius of each sphere is 50 centimeters, right? The moment of inertia system of an axis perpendicular to rod and passing through midpoint. So we have to calculate inertia about this. Now note that this sphere is not like a point mass. Okay, this is a sphere. So you need to calculate each inertia due to each sphere acting about this axis. So you have to use parallel axis theorem. So this distance between this center of mass parallel axis and this axis, that is 75 centimeter. So due to each sphere, that is I center of mass plus md square, right? This is the parallel axis theorem, and there are two spheres, so you can multiply by 2, right? Then you can do this calculation. So I center of mass for the solid sphere is 2 by 5 mr square plus md square, multiply 2 times, substitute the values, and radius you have to put in meter. 50 centimeter is 0.5. Okay, so and this distance again 75 centimeter, 0.75 square into 2, multiply, this will come to 0.65, and this is given as x by 20, so x will be 20 times 2.65, which will give us 53, right? So I hope you have understood these questions. These are the recent year questions which have come in JEE Main, and these are the standard model questions. I hope now you can work out questions on this topic. So with this we have completed this chapter. Then we will move into the next chapter, which is gravitation. Thank you for your attention, and let's remain connected.